All right, welcome to my presentation about the Sanitizer API. Welcome everyone. So, unfortunately, cross-site scripting is still a largely unsolved problem in practice. I mean, on the one hand, we have lots of advice and toolings and mitigations, but on the other hand, XSS is still the most reported security vulnerability for the better of a decade. And I believe that with recent trends in, for example, single-page applications and Electron, a growing number of those XSS vulnerabilities are DOM-based cross-site scripting vulnerabilities. So today I want to talk about DOM-based cross-site scripting and how I believe that it could be tackled more easily with a sanitizer that would be built into the browser. We will also go through some roadblocks that we've encountered in our journey so far. And the Sanitizer API is currently a draft in the W3C incubator group, and there are prototype implementations in Chrome and Firefox. By the end of this talk, you will know what the Sanitizer API is supposed to be doing and how to test whether it actually delivers. And this specification is joint work with Mario Heiderich and Daniel Vogelheim. All right, my name is Frederik Braun. I'm a staff security engineer at Mozilla here in Berlin. And I've been working on web and browser security as a security researcher, as a hacker, as a teacher, for about 15 years now. All right. Very first, let's take a brief minute and ensure that we have a shared understanding of DOM-based cross-site scripting. And I'm going to use and reuse this line of code throughout the presentation so we can follow along. And what it's doing foo.innerHTML equals evil is that there is some random HTML element called foo, and we are assigning some attacker-controlled string evil. And that's really all it takes for DOM-based cross-site scripting. And an important point that I want to make here is that DOM-based cross-site scripting is really purely client-side and sort of in scope for everything the browser is seeing and doing. As a bit of an aside, I'm seeing this presentation as the sequel to previous presentations of mine, where in 2019 I talked about finding and fixing DOM-based cross-site scripting, specifically in the Firefox user interface, where cross-site scripting really means taking over the browser outside of the sandbox. And then last year I presented a bit of a generalized approach to help make this work for more or less all kinds of single-page applications or JavaScript web apps. And yeah, the slides of these talks will be linked from this presentation, which I will share after this presentation. But the takeaway really is that I found and fixed lots of DOM-based cross-site scripting issues in the past, and I kind of observed lots of various people trying to fix those with, let's say, mediocre success. And the approaches I noticed, I sort of grouped them into 3 different categories. Oftentimes, people didn't actually want to use HTML at all, and they could just, fix this by assigning to foo.text content instead. And then there are some where people try to do some smart encoding and escaping, and it sometimes worked and it didn't. And then there were also some where people really did want to mess with HTML, and they had, intertwined spaghetti code paths where somewhere there was a template and somewhere else there was some sort of user input, and at the very end it all comes together and it causes DOM-based cross-site scripting. And I believe that most of all of those bugs, not just, the last half of how they were fixed, all of those could be fixed with a sanitizer. So this is a sanitizer presentation. Let's talk about sanitizers. What would we expect of a sanitizer to do exactly? In essence, the implementation of a sanitizer can be grouped into 3 steps. First of all, the HTML sanitizer is taking some sort of input and passing that string into an HTML representation, for example, a tree or a document or whatever. Second, the HTML parser will take that tree representation of the HTML and walk through the tree, look at all the elements and attributes that might be undesirable. Third, the sanitizer is going to take that tree representation that has now been modified or sanitized and serialize it back into string. This isn't something that every sanitizer will do, but oftentimes they will serialize at the end. Throughout this presentation, I will use the term serialization for the step from tree representation to a string, and the term parsing for, taking the input string and making some sort of tree representation. Let's note in this specific example that the very first step, the parser, already had to decide where this unclosed P element had to be closed. And also obviously how this on-error attribute had to be removed happened in the second step, in the sanitize step. So the final resulting string doesn't only have the on-error attribute removed, but also the P element closed. This will be important later. One single takeaway, I believe, is that the HTML parser, sanitizer is mostly an HTML parser. And the clear benefit I see in the context of the sanitizer API is that this security tool can reuse the parser that is already in the browser, which makes it kind of future-proof for all sorts of developments in the HTML syntax. And I believe that's a huge benefit. So when providing this as an API, we thought about various things we want to do. And let's think for a brief moment what we would require of a sanitizer to do besides these three simple steps. So the goals we had in mind when working on the sanitizer, and we'll go through them one by one throughout this presentation. First of all, we believe it's time that there is somewhat canonical definition of a safe subset of HTML that is known to not cause cross-site scripting. Because when you now look at a sanitizer, or you look at N sanitizers, you find N definitions of what they think is safe or is not safe. Secondly, we really want the sanitizer API to be safe by default. That means there is no possible way that using the sanitizer API will lead to cross-site scripting in an application. Next up, we really want to avoid all kinds of parsing mistakes. Again, I said we want to use the parser that's built into the browser. And next up, we do want the sanitizer to be configurable, right? I'm pretty sure there are many applications out there that have an opinion of what they deem as safe HTML. And I want them to be able to use it in a much stricter fashion than what we default to. But most importantly, we believe that the sanitizer API should not be configurable in a way that does violate the second principle here, that does result in XSS again. And next up, I believe it's time for some sort of responsibility shift, that fixing cross-site scripting is not really the task of every single web developer out there, but really the task of the browser. And if it becomes a browser bug, it will hopefully be fixed more quickly than, very individual web application security bugs. Okay, so I suppose we remember this one from before. In the end, what I want the sanitizer API to do is really provide a safe version of this. Basically say, here is an element, I want to append some HTML stuff to it, but I don't want to cause cross-site scripting. So really, the first idea we had was sort of admittedly a black screen, heavily inspired by various libraries out there. And in the end, we think maybe there should be a sanitizer constructor, and then you pass some options, configuration and whatnot. And in the end, you want to sanitize some input, and then you have, fixed cross-site scripting. But rethinking about our very first idea, and, using it in our example line, we kind of realized two things, and I will walk through this slowly. First of all, let's recap. The sanitizer is, again, parsing, sanitizing, and serializing. But what is the inner HTML assignment in the next step, in the same line of code really doing? Well, inner HTML is parsing the output of the sanitizer and then appending it to the current document. So now we're using two parsers again. Parsing twice is bad. I believe most of you might already know this, but when you parse things twice and in a somewhat different context, then any tiny difference will be used by an attacker to misuse the two different interpretations and cause security issues down the line. This is also known as MXSS or mutation XSS. And secondly, it's also very inefficient to parse basically the very same input twice. So this is the API that we came up with after this realization, which seemed a bit more reasonable. We default to a nice function called Sanitize that gives you a document fragment, which is basically a DOM detail of an HTML element with some elements underneath. And we still give this ugly function called Sanitize to string to developers if they really want a string. And then we tell people to sort of use this. And here we were. We had this implemented as a prototype in Firefox and Chrome, and we were looking for feedback. And as you know, when you work on something that you feel is important, you wait for feedback and you don't design it just by yourself. So we were kind of looking for bugs here, and people had bugs. I'm going to present two of them, but naturally there were more. So the first one wasn't even a security bug. A colleague of mine, Anne van Kesteren, who is editor of, or co-editor of the HTML specification, said, well, the Sanitizer API is just less expressive than in HTML. And I said, yeah, okay, well, and admittedly, I didn't really completely understand what he meant with less expressive. For a long while, I didn't really get the bug, to be honest. But the example he gave is really interesting, so I'm going to share this with you. So without the Sanitizer, when you have a table element and you assign through inner HTML a table row and a table cell, then naturally you will get a table row and a table cell with a table element. But when you're using the Sanitizer, you don't. And why? So, and in fact, an important thing is that, for example, in the HTML syntax, there are different definitions of what's supposed to happen when you do inner HTML equals for different types of elements. So the HTML syntax is actually very verbose about all the things you can put under one element and some others. And one tiny takeaway from long studies of the HTML specification is that there are really two parsing algorithms in the HTML specification. So the first parsing algorithm in the specification is the document parser. It more or less assumes nothing. It consumes bytes, including, for example, a doc type, a character set, and whatnot, and it gives you a full document. That's not really useful for our use case, right? Because we're not dealing with full HTML documents. And then there's the HTML fragment parser, which basically just takes a tiny bit of HTML. But notably, the fragment parser is not just an algorithm that takes input, it takes input and a context, which is really important for the parsing of HTML. So given that our Sanitizer API implementation shouldn't return a document, we kind of try to use the fragment parsing algorithm underneath. Oh, and that's the slide that I probably should have skipped to a minute ago. So the really notable thing is that you need to parse given some context. And going back to the specific example, table element in HTML is supposed to work radically different from div.inHTML. And what we had in the first iteration of the Sanitizer API implementation is some sort of cheat. We made up a context element more or less on the fly and said, it's probably going to be used in body. And that's actually something that lots of Sanitizer libraries out there do. And it works for them, right? They usually don't have to deal with, let's say, table cells specifically. And it's fine for a library to basically support a subset of HTML. But for a web API they want to ship in all browsers, we kind of have to support all of HTML. So that really didn't work for us. And before I show you how we solved this specific issue, I'm going to show you the next bug, which is kind of another puzzle piece of the solution we came up with. The next bug was a true Sanitizer bypass, filed and reported by security researcher Michał Będkowski. And I'm going to walk through this with you, but slowly and step by step. So don't worry. Let's note how this example is taking some sort of string and then putting this into the Sanitizer API and then afterwards putting this into iframe source doc. In the first step, when the input is passed through sanitize to string, we get a representation like this. There's an SVG element, there's an SVG font element, there's an SVG title, there's an HTML view element. All right, then the sanitizer, of course, it has to serialize it because the function that's returning a string. And then we get this kind of source code, which kind of looks the same: SVG, font, title, view element, and the image thingy is still within the rel attribute of the view element. But now, when it's being passed in the iframe source.assignment, assignment, it's going through the document parser. So the document parser has a different notion of how to parse this bit of HTML. And you end up with an SVG element, an HTML font element, an HTML title, and an image. And that's, that's where the cross-site scripting occurs, and that's very undesirable, right? We said the Sanitizer API shouldn't ever allow some sort of cross-site scripting. So my takeaway was to, just burn all parsers. We are reminded again that parsing twice is really bad for good reasons, and also it's less efficient. And I don't ask you to read this. I just want to say I was really angry. I wanted to provide an API that was useful and usable for developers out there, but I'm going to save you months of my agony and tell you what we came up with as a result. And this is kind of how we envision the Sanitizer API right now. And I believe the beauty of that is we can have all the things that I mentioned before. We are parsing this evil string in the context of a specific element. We do specify a sanitizer that explicitly say how it should be sanitized, and we can append it to the document in the very same step, so we don't have to parse it again later on. And what I believe the very best thing about this is that given that the sanitizer in a default configuration is guaranteed to never cause cross-site scripting, we can make it optional. And that's pretty much the shortest, and especially in comparison, a shorter version of saying append some stuff to some element and don't cause any cross-site scripting. And it's supposed to be guaranteed by the browser. So if someone finds a cross-site scripting issue in a code line like this, that's basically not your problem as a web developer, but it's a browser problem. So hopefully someone gets a bug bounty and it's fixed. Naturally, nobody should believe someone who's standing on stage and saying, this is secure. So here are some further security considerations and the fuzzy edges of our threat model. And we will walk through those topics step by step. First of all, server-side XSS is naturally completely out of scope for the Sanitizer API. First of all, I started by talking about DOM-based cross-site scripting, right? So remember, this is about DOM-based cross-site scripting. Secondly, some of you might believe, hey, but I can do JavaScript on the server, right, with Node.js. Yes, but Node.js does not have an implementation of HTML or the DOM. And if it had, I'm pretty sure it wouldn't match the implementation of the browser that your user might be using. So you could do that, but you'd be at risk of reintroducing parsing issues, which maybe you don't want to. Next up, DOM clobbering. I'm going to explain this attack for a second. I believe this attack was first described by Gareth Hayes in 2013. And the idea is that you're injecting some sort of HTML elements to confuse JavaScript code down the line. And in this example, someone's injecting an element with a name attribute of child nodes, and then code below will basically try to walk through the child nodes of the form element, and it won't actually walk through the real children of the form element, but through just those that have been injected, which is kind of unfortunate. By default, the Sanitizer API, as it's implemented in a browser, is not implemented in JavaScript. So when it's iterating over DOM tree, it's not looking at fake injected stuff, naturally. But when you as an application developer or a security researcher want to figure out whether the Sanitizer API protects websites against DOM clobbering, then the answer is yes-ish, but not by default. So someone can say we don't want name attributes, we don't want ID attributes, and then DOM clobbering will be addressed by the Sanitizer. Another attack that I believe was first described by Sebastian Likis and Christoph Kotowitz in 2017 was called XSS with script gadgets. And the idea of a script gadget attack is that you're not injecting HTML or XSS directly, but you're using or relying on a framework or a library or some sort of third-party software to do the cross-site scripting for you. So you're injecting some sort of framework or library or template syntax, and you're causing XSS down the line. Again, the sanitizer cannot prevent all of those attacks because we don't want to or should know how all of the frameworks in the world look like. But again, if you're in the context of a specific framework, you can configure the sanitizer to acknowledge all of those things and remove them. And ideally and long term, we are hoping that frameworks out there will basically construct the sanitizer for code within that framework that will be configured to be safe in the context of the framework. Lastly, I briefly want to talk about MXSS again, which I believe I touched on a bit before. It was first discovered by Mario Heiderich and others. MXSS happens basically when the parser is taking an HTML input string, doing something with it, and then it's being parsed again, and suddenly it's something completely different. This example is from Internet Explorer, which I believe is fortunately a thing of history, I guess, unless you're using Office and so on. But and when you have a parser parsing stuff like that, you can't really, sanitize properly. So MXSS is not completely solved with the Sanitizer API as long as you parse again. On the flip side, that means the sanitizer really wants to help protect against MXSS, but whenever you parse again, you might be in deep trouble. And as I believe I mentioned before, nothing good is ever developed with feedback. So I'm pretty sure this might work, but it won't work if there's not more feedback and bugs to be found by the security community. So I'll be presenting 3 ways in how you might be able to insert yourself into how we currently develop the Sanitizer API. First of all, this is a security conference, so I suppose people are looking for bug bounties. And there are some relatively easy steps to test the Sanitizer API. And you basically just have to enable the sanitizer in Chrome or in Firefox. You do these steps. Then you go to an empty web page, open developer tools, and you do document body set HTML evil. And if it XSSs, well, then you profit. And you should tell us about it. Otherwise you won't. Secondly, it's still a so-called draft, so it's not yet a specification, and we are also basically changing how it's supposed to work. And there are some really interesting and sometimes gnarly open questions in the specification. So if you want to take a look at the open questions or maybe even participate, we invite you to join us on GitHub. And talking about GitHub, there are also some things you can do if you want to code. First off, there's a test suite called Web Platform Tests, which is a test suite that is shared amongst all browsers. And when you submit tests, they will be run against all browsers. So there's huge value if you would want to write some test case for web platform tests for the Sanitizer API. And secondly, if you want to share some of my agony, you can also try and participate in the implementation of a polyfill, which is currently really early stages, doesn't really implement the spec, doesn't really match the browser. So there's lots of fun to be had. So my takeaway for today is to burn all parsers, or really, if you believe you need a sanitizer, then make sure you're using the right HTML parser before, after, and in the middle, and make sure you use the right one. Thank you. Thank you for your attention, and thanks to all the people who already helped out with the sanitizer. And I will be available for questions here, but also during the coffee break. And I'm on Twitter, and my email address is freddy@wizard.com. So.
Thanks for the talk. Very interesting. I have a question. I got lost when you told that you were using the document parser and then how was the
fragment parser?
The fragment parser, and you got an issue. and you launch a new version of the API or something like that. So I just want to understand in which component of the browser this API sits. Like, I don't got that part.
So basically, when you're visiting a web page, right, you type in an address and you press enter, then the browser is taking a response from the server, and it's using the document parser because it's expecting a full document. Yes? Okay. And when you do something like foo.innerHTML equals, it's not taking a full document. That's why it's parsing stuff a bit differently. It's using the so-called fragment parser. And the most important thing for the fragment parser is that it's contextual. So if you do body.innerHTML equals, then you can basically assume and accept all sorts of HTML elements. But if you're in a table element, then there are special rules for how HTML tables are supposed to work. For example, you can't have, I'm lacking good example here, but the flip side was really, if you're not in a table element, you can't really accept table rows and table cells without the outside table element. Another really typical example is the HTML select element, which I believe only accepts 4 different elements, mostly really options elements. So it's really just a thing of the HTML grammar that makes parsing a bit tricky.
Okay, just in summary, you put your API code inside the fragment parser. So that's the thing. So I want to understand in which context the parser is running or where in the browser is running.
Yes, so in the Sanitizer API, in this very specific case, we can instantiate or call the fragment parser using the context element foo, and then we're using the right parser with the right context. That's the takeaway.
Okay, thank you.
We can talk at the coffee break if you want.
Great presentation, thank you.
Thanks.
I was wondering, because the Sanitizer, at least in this form, right, it totally solves as a replacement for the inner HTML function on an element in a way that's roughly safe for the majority of the web. How do you envision tackling the source doc problem? Like, if a web developer wants to, I guess, instantiate or call into the document parser for an iframe source doc attribute, like, given that the Sanitizer is based on the fragment parsing algorithm, what should the developer do to have safe iframes, I guess?
It's really one of the open questions we have on GitHub right now. So the idea is that we also think about providing a sanitize function that will accept an existing document or document fragment and sanitize that. So you can have something parsed, but that's probably not really useful for...
Yeah, not for the iframe, to my understanding, not for the source doc, right? Because then you need the other parser completely at a certain point.
Well, basically in that case, you would have to parse yourself correctly and then sanitize, which admittedly is more brittle than the approach we are presenting here. Yeah, but there has also been a suggestion for some sort of source doc setter that auto sanitizes. But so far, I'm not super convinced that this is the most exciting use case, but it's probably an existing one. So we'll think about this some more.
Yeah, thank you.
Thanks.
Hey, thank you. I really like the idea of a big company like investing lots of effort into HTML sanitization. But I think it's not obsolete to like do server-side sanitization. Is that correct? It's just an extra line of defense because maybe I want to give my client, when he enters some text, some feedback and say, sorry, nice try, but that's forbidden. So I think it's just an extra step taken, but I think that server-side sanitization is really important, and I think it would be cool if you like have a command line tool out of this so we can use it on the server side, because maybe we do not even have access to JavaScript and like build our website in a different way. Well, we've got not another engine that doesn't support Sanitizer.
Yeah. So first of all, I want to acknowledge that cross-site scripting in general is a really, really, really big problem that we solve here. And we're starting small. So we're explicitly starting with the DOM-based cross-site scripting because we know everything is more or less in the context of the browser. So we can, deal with it from sink to source, so to say. But admittedly, down the road, I believe there might be more solutions for more complicated setups, which may or may not involve server-side things. But again, an important thing that I wanted to bring home throughout this presentation is if you sanitize someplace else, for example, in the server, then you're parsing in the server and you're more or less guaranteed to mismatch with how the browser is going to interpret this. So even if you believe that you're sanitizing really, really well in the server, I wouldn't completely, at least from a very, purely theoretical perspective, I wouldn't really believe that the output is always guaranteed to be safe, really depending on how it's going to be used in the document in the end.
And that's why I wanted to use like your tool and have a browser engine, so that it's
that could be possible, I guess, but then in the right now already, I was going to say in the worst case, but realistically, every browser is implementing HTML a tiny bit different. And take, for example, I don't know, the portal element, which some browsers support and some don't, or some parsing bugs that you may have. So if you wanted this to make it really secure, you'd have to have all browser engines in the backend and always match the client, which I believe nobody thinks is a good idea. But I believe that one of the benefits of the Sanitizer API in the long run can also be that once we've defined this safe subset of HTML in the HTML specification, we can definitely go out to other sanitizers and say, what's your use case for having a different one? Let's converge. And then I believe there's also lots of fun to be had and, mismatching less.
Hello. Thank you for your presentation. So my question is, what is it that you are doing different than the other sanitizer, let's say Google Sanitizer and Cure 53 Sanitizer? I think they have. So what is it that you are doing different, and how you are approaching the problems they have? For example, when it comes to the mutation XSS.
So I believe the core benefit is really to, again, integrate this into the current parser that the browser is defined to use, so that there is less risk of mismatches. And maybe I didn't emphasize this strong enough in the presentation, but MXSS in the context of sanitizers is quite a problem. So I believe that, or at least I know of no sanitizer out there that hasn't been riddled with some MXSS bugs.
Yeah.
And integrating this directly in the browser sort of mostly protects us from this.
Okay.
Thanks, great talk. It's 2022. Why do we have XSS still?
Yeah, it's an embarrassment, right?
What do we need to do to eradicate it?
It's gonna take some time, but I believe this is a good step. But if it's not, tell me. Yeah, I don't have a great answer for that, but I'm sure Christoph has an opinion. We'll talk at the coffee break. So yeah, I mean, that was the start of my presentation. I truly believe it's quite an embarrassment of the web platform to still have this simple bug not solved. And we tried, right? There have been lots of mitigations and tools and even browser interventions like browsers had cross-site scripting filters that didn't really work that well. So yeah, I don't know. I'm the security engineer. I'm not the application developer. Basically, it's never my fault. Thanks.